अच्छा सर, आवाज आ रही है?
जी सर, आ रही है। यस सर।
अच्छा, बस इसको कंप्लीट कर लें कि ये वायर्स बीच में डिप कर लेते हैं। तो एक वन टर्मिनल इज पॉजिटिव, द अदर वन इज नेगेटिव। ठीक है, सो वन ऑफ द सॉल्यूशन इज, well, it's a buffer solution, it's got ions. The other solution, just like electrolysis. So electrolysis, what would happen? The ions would travel, right? Now this amino acid is a zwitterion. So if the amino acid is a negative zwitterion, like this thing turns -1, and there is R. So if it's a negative zwitterion, then it will get attracted to, so then it will get attracted to the positive side. Okay, just like electrolysis. And if vice versa, if it's a positive zwitterion, then it's going to get attracted to the other side. And if it's not a zwitterion, if it's a negative ion, then it's going to get attracted to the negative side. If it's a positive ion, it's going to get attracted to the negative side. And if it's a zwitterion, then it stays in the middle. Okay, so the negative ion would get attracted over here, the positive ion would get attracted over here. So remember, every amino acid has 3 states. Okay, it could form a positive ion like this, it could form a negative ion like this, or it could be something that would be in the middle, that is a zwitterion. And the zwitterion would stay right in the middle. So ये बात clear है कि separation is happening. Is this clear?
Yes sir. Sir, can you please explain that part again?
ठीक है, मैं कह रहा हूँ electrolysis is clear है ना कि what happens in electrolysis, you have a positive side and you have a negative side, right? Positive terminal के साथ which things get attracted? Negative ions get attracted to it, right?
Yes
तो
sir.
तो हमने ये भी पढ़ा ना कि अमाइनो एसिड जो है वो, अगर if it's a slightly basic medium, so the acid part would lose an H+1 and it would form a negative ion, right? ये clear है? Or if it's an acidic medium, if the pH is lesser than the isoelectric point, then it would behave as a positive ion. या फिर वो तीसरी चीज पड़ी थी कि which was a zwitterion, कि it could do both things, कि कहाँ गया हमारा zwitterion, this thing, कि it can do both things, कि it can form the negative ion as well as the positive ion, but that would happen if the pH is at the isoelectric point. तो 3 forms है. तो आप एक तरह से इलेक्ट्रोलिसिस कर रहे हो. there's a ये बीच में ना there's a filter paper that is soaked in. उसको भी लेबल कर लें. This is the filter paper. अच्छा, that
So
there's
what
a,
are the two blue drawings?
कौन सा?
The two blue things at the side.
ये तो बस वो एक trough है. It's kind of, there's a solution, there's a buffer solution in that trough. This electrolysis नहीं होता, you have a solution, right?
Yeah.
So it's just any buffer solution, क्योंकि you don't want the pH to change, क्योंकि if the pH changes तो वो amino acid की जो शक्ल है ना वो change हो जाती है. Is that clear?
Yeah.
And you're trying to separate a mixture of amino acids. So some amino acids would be, because every amino acid has a different isoelectric point. So every amino acid would either form a negative ion or a positive ion, or it might be in the form of a zwitterion, right? So depending on what it is, it will either get attracted to the negative side or it will get attracted to the positive side. So जैसा chromatography में separation होती है ना, the amino acids would travel in different directions. Is that clear?
Sir, what about the zwitterion?
वो फिर बीच में वो बीच में ही रहेगा, क्योंकि zwitterion is overall neutral, right?
Yeah.
So if it's a zwitterion like this one, then it would stay right in the middle. If it's a positive ion, it will get attracted to this side or दूसरी side पे. ठीक है, clear है ये बात?
Yes sir.
अब बाकी रह गया कि what is left is that अच्छा, so movement depends on 2 things. Number 1, the charge on the amino acid. तो question यही आएगा. I mean, they're going to ask you a question like the question would be, remember, कोई बहुत complicated questions नहीं होंगे, कोई ये नहीं होगा कि बहुत सोचना पड़ेगा. It's going to be a very simple, like the glycine part that we did. कि वो कहेगा if glycine has a pH of where would glycine move if you do electrophoresis at pH 6.5? If 6 is the isoelectric point, then for it it's a basic medium. It would be a negative ion, and you'll just tell them if since it's a negative ion, the negative ion is going to get attracted to the positive side. That's it. So तो अगर वो कहेगा कि ये है या ये है, so this is glycine. Or then maybe he's going to ask you at pH 5.5, where would you find glycine? So it's going to be a positive ion. So this is the positive ion would travel to this side. So this would be the glycine molecule in that case. So the first thing is the movement depends on the charge on the amino acid. Okay, that's the first thing. Second is movement, or इधर मैं लिख भी देता हूँ कि it depends on the charge on the amino acid. So if it's a zwitterine, stays in the middle. Second one, if it's a if it's a positive ion, then moves towards negative side. That's a third one. If it's a negative ion, then it's going to move towards. There's another thing, and that is it also depends on the mass. How heavy is the molecule? Remember, every amino acid has a different size. Diagram every amino acid. Some of them are really big, some of them are like really small. So amino acids have different masses. So the speed of movement pata lag jayegi. So the second factor is the MR of the amino acid. So if the MR is less, it's going to travel more. Then it travels further. And so on. TK and vice versa. Ye bhi clear? Is this clear?
Yes, sir.
That's what electrophoresis is. So they'll give you a diagram. Let's say you did electrophoresis, and as a result, you put amino acid mixture over here, and you got two spots, one over here, one over here. Which one is the lighter one? This one, right one, or the left one? This one.
The left one.
The left one is lighter because it's traveling a larger distance. ये जो होगा ना heavy होगा. That's why it's moving very very slowly. तो इस तरह के क्वेश्चन होंगे, बेसिक होंगे, कोई इतना कॉम्प्लिकेटेड क्वेश्चन नहीं होगा. ठीक है, एक आध कोई वैसे देख लेते हैं एंड में कि अच्छा इलेक्ट्रोफोरेसिस 9701. अच्छा एक आध कोई, और सारे क्वेश्चन एक ही टाइप के होंगे, कोई बहुत कम वैरायटी होगी इसमें. अच्छा ये आ गया. वो कह रहे हैं electrophoresis can be used to separate mixtures of amino acids and peptides. A mixture of tripeptide and its three constituent amino acids was subjected to electrophoresis at a pH of 11. Draw the structure of serine at pH 11. अच्छा वो पहले डेटा बुकलेट में serine दिया होता था, ठीक है, तो वो क्या है pH 11. pH 11 is obviously extremely basic conditions. तो उसका स्ट्रक्चर serine अब तो वो देंगे क्योंकि पहले डेटा बुकलेट के अंदर गिवन होता था. So serine is, remember, you don't have to remember the structure of every amino acid. Serine as CH2OH, that's the R group. So if I go back to, अच्छा इस पे मैं लिख नहीं सकता, just a second. So serine is going to be, I think it's CH2OH. I mean, you can Google this, but I think that's the one. And it's going to have carboxylic acid one side, H on one side, NH2 on the other side. अब मुझे खाली बता दो कि what will be at pH 11? What would be its what would it be? Would this side turn? Would this gain H+1 or would this lose H+1 in a highly basic condition?
COOH will lose.
हाँ क्योंकि ठीक है क्योंकि basic का मतलब there's too many OH ions, so the H+1 would be lost, and because of that, serine would actually look as a serine would look like this. It will have a negative ion. Then it will get attracted to the positive side. ठीक है ये हो गया और अगले पार्ट पे चले जाते हैं कि उसमें 1 second ये आया हुआ तब वो आइडेंटिफाई करना है तब वो बेसिक हाईली बेसिक कंडीशन में they're all going to have, I mean they're all getting attracted to the, so you have to identify, तो mass के ऊपर ही आइडेंटिफाई करोगे. The mixture is applied here, so you would just look at the mass of the particles. This would be the lightest and this one would be the heaviest. Is that clear?
Yes, sir.
ठीक है. ये पुराने क्वेश्चंस में ना उनमें से one of them is a peptide, which means के alanine, serine and glycine, they're all joined together, so वो amide links होंगे उनके बीच में, but it will still be even if two amino acids, बल्कि कर लेते हैं, एक सेकंड यहाँ पे कहाँ पे इधर तस्वीर बनी हुई थी. हाँ, तो अगर एक दो को मैं जोड़ भी दूं ना, I mean there would be no difference. Like if I join ALA and valine and alanine, तो what happens, वो हमने उसमें polymerization में पढ़ा था ये सारा कि peptides बनते हैं NH2 R group and this side is carboxylic acid, so there's going to be another amino acid, this side would be amine, तो बीच में से H और OH remove हो जाते हैं, they would form an amide link, but otherwise the structure kind of overall remains the same. कि वो बीच में तो चलो they would join up, right? But the right side still has carboxylic acid, the left side still has amine. So even if it's a tripeptide or a dipeptide or they polymerize, but the basic structure still remains. One side is carboxylic acid, the other side is amine. Is that clear? ये बात भी clear है?
Yes, sir. Yes, sir.
तो एक और क्वेश्चन देख लेते हैं कि अच्छा उसमें मेरे ख्याल से उसने if you go back to the question, कौन सा क्वेश्चन था ये वाला? So if you go back to the question, suggest the identities of PNS, I think you'll be able to do that. Identify the components. F is the battery and G is the negative hoga, positive hoga. What would it be? So it's probably going to be the positive side. Okay. If you remember, wo jo serine at pH 11 was a negative ion. So why are negative ions getting attracted to this side? Because it's probably going to be the positive side. It's going to be the anode. Is that clear? You clear?
Yes, sir.
So, and explain your answer with mass. So you'll figure out using mass. Either boil with HCl. This is reactions. Coming back to the next one, or the other one would be also similar. In this case, they're not asking you to actually label it. That's filter papers. Achha. When the power supply is switched on, so when the power supply is switched on, may not move but remain stationary. It suggests why would it not move? Because it says Witter ion. That's the reason. ठीक है. और इसी तरह उसने spots दिए में. So some of them are moving relative size. एक second देना मुझे ना. तो ठीक है ये वो relative size. सबसे lightest कौन सा होगा? It's going to be A. The heaviest would be B because it's traveling the smallest distance. One of them is moving towards the negative side, so that's going to be the positive ion. The two of them are moving to the left side, so they're going to be, तो वो चार्ज भी पता लग जाएगा. ठीक है, क्लियर है बात?
Yes sir, clear है.
चलो ठीक है. चलिए ठीक है, मेरी एक और क्लास है. ये खत्म हो गया, इसके अंदर कोई ज्यादा चीज है नहीं. मार्किंग स्कीम देखोगे समझ आ जाएगा. हाँ जी.
Sir, जब mocks खत्म हो जाएंगे, will we have to come to school for the classes?
वो डिपेंड करता है. वैसे तो हम पास पेपर्स वगैरह की क्लासेस करते रहेंगे, लेकिन अब वो डिपेंड करता है आप लोगों पे. ठीक है, हम स्कूल में ही होंगे.
Sir, we
ठीक है,
can do like 1 or 2 classes a week.
हाँ चलो ऐसा कर लेते हैं कि पास पेपर हेल्प वगैरह उस तरह. ठीक है,
ठीक है sir.
चले. ओके,
अल्लाह हाफिज़.
अल्लाह हाफिज़.
सर,
हाँ जी,
आप ये रिकॉर्डेड लेक्चर भेज देंगे इसका, और नोट्स भी क्रोमेटोग्राफी और इलेक्ट्रोफोरेसिस की.
हाँ मैं ये दोनों भेज देता हूँ. ठीक है.
ओके, थैंक यू सर. अल्लाह हाफिज़.